Hey everybody! So for today's mini lecture, in the lesson on Toadstool Park, I briefly mentioned structural geology. And so I wanted to kind of delve into what structural geology actually is and give you a little introduction on some of the features that have been seen in this lesson. So first of all, rocks can be deformed. So rock deformation is the process by which they are bent or broken when stress is applied. There are three main types of stress. Compression, where you're pushing two things together or compressing them. Tension, where you're pulling those things apart. Or shearing. And shearing is probably the hardest for you to visualize, but that's when things are sliding past one another or grinding against one another. The response to these types of stresses can range from ductile, where things kind of bend and fold, to brittle, where things break. So again, I just kind of described these, but stress is defined as any force which acts to deform rocks. So it's a form of directed pressure. Again, you can have the three types: compression, where you're forcing the objects to be pushed together. That's shown in the top right image. We're having force coming from either direction and pushing our rocks together. Tension is a force of pulling objects apart, or also known as extension. And that's in B here on the image to the right, where we're pulling the rocks apart. And then shear stress is the force of sliding those objects past each other. So you've got kind of two different directions and they're moving against one another. And then strain is another term here, which is the change in shape of the rocks as a result of those stresses. So stress exerts strain. Now I mentioned there are two types of deformation. There's brittle, which is the breaking or shattering of rock material as a result of stress being applied. So that's shown in this image on the left. You can see this line right here, and that is where our rocks have broken apart, and then that breakage created a surface where the rocks slid past one another. And then finally, we can have ductile deformation, which is the bending or folding of rock material as a result of that stress. And that's shown in the right image. These rock layers have been deformed ductily, so they've bent or folded here. So here's just two examples of brittle deformation. On the left is brittle weathering, and then on the right is another one of these faults, and we'll talk about what faults are in a moment. And then here's another example of ductile deformation. So this is on the left are some grains that have been pulled and kind of squished together, pushed, and then on the right is actually a deformed trilobite. So you can get deformation of fossils as well. Now, what's relevant to this is what's actually going to cause brittle versus ductile deformation. What makes it different? Why does it break versus why does it fold? So temperature is a big reason why something would break or fold. When it's warmer or deeper down where we have really hot temperatures, it's going to show ductile behavior. Think of if you were to warm silly putty in your hand. When it's colder, rocks exhibit brittle behavior. So when it's closer to the Earth's surface, you're going to get brittle behavior. So at high temperature, this happens because molecules and their bonds are capable of stretching and moving. Pressure also influences this. So rocks under great pressure are actually more ductile than those at low pressure. So that kind of factors in there. And then the rate at which the deformation occurs. So gradual changes tend to produce ductile deformation where the rocks fold, but sudden, very fast changes tend to cause brittle deformation. And then finally, composition can have an influence. So some rocks and minerals are simply softer and they can deform more easily, whereas some are simply harder, so they break. What's most relevant to the lecture today is brittle deformation or faults. In the Toadstool Geologic Park, there is the Toadstool Fault. So faults are fractures in rock created by stress where one body of rock slides past one another. Fracture is created by brittle deformation of the rock, just to reiterate. And then there's different components. We're not going to really go into this. But when you're looking at these different components, let's move to this next one. There's a hanging wall and a footwall, and this is relevant to today's discussion. So the hanging wall is the top block where your head would touch if you were to stand on the plane of breakage. So the fault plane is the line upon which the rock is broken, and if you were to stand on that plane, you would hit the hanging wall block. Another way of remembering it is, say you were to be hanging off the side of this block, you would be hanging there, hence a hanging wall. Whereas on the footwall, you could slide down it. It acts as a slide. So this is important because whether the hanging wall moves up or down determines what type of fault it is. So here are the different types of faults. So you can have dip-slip faults, which is when you get upward vertical movement. When there's a normal fault, your hanging wall has moved down in relation to the footwall, and that forms from tension or extensional stress. When it's a reverse fault, also sometimes referred to as a thrust fault, you have the hanging wall move up in relation to the footwall, and that forms from compressional stress. There's also strike-slip faults, which form from shear stress, and that's basically we have two planes moving past one another again. So here's our example of our normal faults, and this is what you're going to see at toadstool. The toadstool fault is a normal fault. So again, normal faults form from tension, forces that are pulling things apart, and the hanging wall moves down in relation to the footwall. So there's an image of that, just another example in the bottom, and then a diagram depicting that type of normal fault at the top. Now, you can also get reverse faults. So reverse faults are when the hanging wall moves up in relation to the footwall block, as shown in the top diagram. And this forms from compressional forces, where you're pushing two blocks together. And again, there's just another example down at the bottom. And then finally, here's our strike-slip faults. So the type of strike-slip fault is really just dependent on the direction of which those strike-slip faults have moved. And the way you can kind of tell this is if we were to be standing on the red star here, we would ask ourselves what direction the rocks across from us have moved. So in our case, where the purple star is. And if we were standing on the red star, it would have moved to our right. So that would be a right lateral strike-slip fault. And some of these terms aren't really necessary to remember for this, but I wanted to give you all an introduction to what structural geology is and go over at least what faults are and what brittle deformation is in a little bit greater detail so that you understand what that toadstool fault is in this lecture. Again, as usual, continue to go through to the Toadstool Geologic Park area is a very interesting geologically rich area, and I am excited to see what interests you most. So I hope you enjoy.